Okay, so part 4 is off page 613, problem 13. We're going to test the convergence or divergence of arctangent n over n squared plus 1 with the integral test, which means you just simply take the integral of arctangent n over n squared plus 1. You keep the same limits that were on the sum. Alright, if you recognize, make your u the top arctangent, and derivative of arctangent was used to 1 over x squared plus 1, or 1 over 1 plus x squared, but I try to keep the same order, 1 over n squared plus 1 dn. So they've given you a simple u to u with no fix needed. Substitutes as u to u. Add 1, divide by that, u squared over 2. Again, I've dropped the 1 in infinity. Now I plug back in for u being arctangent n. You get arctangent of n squared over 2, put in 1 in infinity. You get arctangent of infinity squared over 2 minus arctangent of 1 squared over 2. We did mention before we left that arctangent of infinity was pi over 2. Pi over 2 squared divided by 2. Arctangent of 1 is pi over 4. Squared divided by 2. If you work through the arithmetic on the fractions, pi squared over, you'll get 2 squared is 4, and when you multiply by 1/2, wind up with pi squared over 8, minus pi squared over 32, and you'll wind up with 3 pi squared over 32, because 8 times 4 is 32, 4 here, 4 pi squared minus pi squared is 3 pi squared over 32, which is finite. Don't really care what it is. It is finite. So we can conclude that the original series, sum of arctangent n over n squared plus 1, and there should not be a dn there, my apologies. No dn on these, that's dn's only on an integral, converges by the integral test. On the next example, problem 29, we are going to test sum of n equals 1 to infinity, 1 over n to the 7 by the integral test. Now you could also use a p-series on this. The idea is to show that these tests are completely and totally consistent. P-series, it's p greater than 1, it clearly would converge by the p-series test. But an integral test, you take an integral of 1 over n to the 7th, make that n to the negative 7, add 1, divide by that, n to the negative 6, divide by negative 6. Put that power, or negative power, you can put in infinity now, infinity, and then you can switch the power down. 1 over negative 6, infinity to the 6, minus 1 over 6. Lead term will be 0, plus a 6, you get a finite result, so that converges by the integral test. My 30 seconds is up, or 3 minutes is up, so we will come back with, I believe, part 5.